Welcome back, students. This is Mark Anderson for Kellogg Community College, and we are going to be solving some radical equations. And these are going to be pretty tricky just because they're going to involve a whole lot of FOIL. We're going to have binomials that we'll have to distribute, and it's going to take some very precise algebra to do these problems correctly. So, here we go. So our goal here is to find out what x is. You'll note that we have an x and a square root of x. No matter what manipulation we have to do, we're going to have to do some squaring, and a good strategy is to try to get the radical all by itself on one side. So I'm going to subtract 2 from both sides, and this is going to give me x minus 2 is equal to the square root of x. Now, by getting this all by itself, the way I can get rid of this square root is to square both sides. And what that means is on my left-hand side here, I'm going to now have to FOIL this. A common mistake is a lot of people will just say, oh, that's x squared plus 4, but that only works for monomials. This is a binomial, and the definition of squaring is writing something twice, and you can see that this is going to make the left-hand side a FOIL. The right-hand side will be just x. We're going to do our FOIL on this side, so we have x squared from our first terms, minus 2x from the last terms, that's our O of the FOIL. Our I of the FOIL, the inside terms, is minus 2x, and our L, or the last terms, is going to be 4, and that's equal to x. So now I'm going to move this x to the other side, since it looks like we've got a quadratic going on here, and there we have our answer of x squared minus 5x plus 4 is equal to 0. Now, I could use quadratic formula, or I could use factoring to solve for this, and I'm going to use factoring, since it's pretty easy to find two numbers that'll multiply to make 4 and add to make negative 5. Those numbers are x minus 1 and x minus 4. Those are both equal to 0, so let's go check here. I am going to now solve for x by setting these equal to 0. Alright. And then I'm going to move the 1 over here and get an answer of 1 by adding 1 to both sides. Move the 4 over here by adding 4 to both sides, and that will give me 4. Now, bear in mind that both of these answers may not actually work. It's best to check your answers when you get done. So if I go and check my 1 and plug my 1 in for this into the equation, I get 1 plus, or sorry, I get 1 is equal to the square root of 1 plus 2. So 1's equal to 3? I don't think so. So 1 is not a correct answer. Here I'm going to plug the 4 into this equation, so I'm going to have 4 is equal to the square root of 2 plus 2, square root of 4 plus 2, and that's going to give me 4 is equal to 2 plus 2, and that's right. So 4 is my answer to the problem. So it's best to look at these problems and check your answer when you're finished with them, because it's possible you might have an inconsistency. If we look at this problem here, one of the best things about it is that the square root is actually all by itself already. So I'm going to square both sides to get rid of the square root. On the left-hand side, this still remains as 3x plus 1. On the right-hand side, I have to write this twice because it is going to be FOILed. So my 3x plus 1 is now equal to x squared minus 9x plus 81. Now if I got to move everything over to one side here because I'm going to either factor this or I'm going to use quadratic formula, and I want my x squared to be positive to make this easy. So I'm going to subtract my 3x from these other x's here and subtract my 1 from the 81. So that's going to give me 0 is equal to x squared. Negative 9, and negative 3 make a total of negative 21. And the 80 is, or 21x, excuse me, and that's going to give me 80 here, 81 minus 1. I could use quadratic formula, or I could use factoring, and I think I'm going to use factoring. I'm going to think what two numbers multiply to make 80 and add to make negative 21. Well, one number that jumps out at me is, I wonder if 80 is divisible by 5, and it absolutely is. It's divisible by 5 16 times. And 16 and 5 make negative 21 if I made both of them negative. So x minus 16 and x minus 5 both set equal to 0. So let's now solve for x. X minus 16 is equal to 0, or x minus 5 is equal to 0. By moving the 16, I got x equals 16. And by moving the 5, I got x equals 5. So, what I'm going to do now is check to see which one of these work. Check my answer here. I'm going to go 16 times 3, which is 48, plus 1 is 49, so that gives me 7. And 16 minus 9 is 7, so the 16 works. Now if I check out the 5 here, this is going to be 3 times 5, which is 15, plus 1, which is 4. But then I get x minus 9, and that gives me a negative 4, so this does not work. So my answer to the problem is 16, not 5. Alright, so for the second of these, let me just give a little bit more headroom there. Alright, so for the third problem of 6 that we're going to do in this video here, we have another problem where, lo and behold, everything is kind of beautifully, the square root is all by itself here, so we're going to square both sides, square both sides. So we got 2y minus 6 is equal to, and I'm going to FOIL this out because this is 3 minus y and 3 minus y. So if I distribute that, this gives me an answer of 9 minus 3y plus y squared. Now this 2y minus 6, I'm going to move it to this side because my y squared is already positive. So I'm going to subtract my 2y from these bunches of y's there. I'm going to add my 6 to this 9 right here. And I'm also going to take this opportunity to reorder all of this on the right-hand side due to the commutative property. So the y squared will go first. Then we'll go minus 3 minus 3 minus 2. That's a total of negative 8. And 9 and 6 make a total of 15. So I will now use my factoring skills to figure out, hey, what two numbers multiply to make 15 and add to make negative 8? Well, that's going to be negative 3 and negative 5. So it looks like my two possible answers for y is going to be y is equal to 3 and y is equal to 5. Now you can see that I skipped some steps here where I should set y minus 3 equal to 0, but then I just move the 3 over and get an answer of 3. Set my y minus 5 equal to 0, and then, again, add my 5 to both sides to get y equals 5. So which one of these answers is right? Let's go check it out here. Let's go with 3 first. 2 times 3, which is 6, minus 6 is 0. Square root of 0 is 0. 3 minus 3 is 0. So this one checks out. Let's try the 5. 2 times 5 is 10. 10 minus 6 is 4, which is good. Square root of 4 is 2. And this is 3 minus 5, which is negative 2. Yeah, doesn't work. So my answer to this problem is 3. Okay, so here's our fourth problem of 6. And you'll notice that, wow, I'm not sure I can get the square root on both sides to be all by itself. And you're right. So what we're going to do is square both sides and just kind of deal with the fact that we're going to have to square this FOIL, or FOIL this with a square root inside. Now this gives me x minus 7, and on this side, this gives me, if I write this twice, the square root of x minus 1 and the square root of x minus 1. Well, let's do our FOIL here, and let's be careful as we do our careful FOILing. The square root of x and the square root of x is the square root of x squared. The square root of x times negative 1 is negative square root of x. The square root of x and negative 1 is negative square root of x. And 1 times 1 is positive 1. So here's what we have. We have x minus 7 is equal to x. Notice that that's what the square root of x squared is. Minus 2 square roots of x plus 1. Well, I'm going to get all of my terms over to the left-hand side except for the negative 2 square root of x. So I'm going to subtract my x from both sides, and I'm also going to subtract my 1 from both sides because I'll just figure out a way to get rid of this soon. But hey, check this out, man. Those go away. That's pretty nice. Those simplify to 0. So negative 8 is equal to negative 2 square root of x. Wow, this is incredible because now I divide by negative 2 and I get the answer of 4 is equal to the square root of x. And great, now I just square both sides. So if I square both sides to get rid of the square root, like I did up there, I get an answer of 16 equaling x. And I probably should check my answer here, so let's go with that. 16 minus 7, that's going to be 9. The square root of 9 is 3. Okay, let's try this one. 16, square root of 16 minus 1. Let's see, square root of 16 is 4. 4 minus 1 is 3. Hey, it works! It works. That is a very, that is very good. Very good that nothing came up weird there. Alright, so now we have a problem, the fifth and sixth problems, the real doozies of this whole video here. Because no matter what you do, you're going to have some awful factoring and foiling here, because now what you have on this left-hand side, I mean, we just have to square both sides. There's no way to move the 1. This is a real sad situation, but it's one that we have to deal with. So what this means on the right-hand side, all the way over here, this is just going to be x plus 12, and that's fine. But let's now see what this happens. This is the square root of x plus 7 plus 1 twice. I got to write this out twice. X plus 7 plus 1. All right, so here's what we got. We are now going to FOIL this out. So I'm going to FOIL this and this. So that first cable of the square root of x plus 7 times the square root of x plus 7 is the square root of x plus 7 quantity squared. All right, because we can do this. We can multiply as long as they're within inside the same root. But here's the funny thing. When I multiply the square root of x plus 7 times 1, I just get the square root of x plus 7. And I do the same thing for the I cable here, and I just get the square root of x plus 7 again. And then 1 times 1 is 1, and that's equal to x plus 12. Well, let's see what I can do to simplify this. Okay, on this left-hand side here, the square root of x plus 7 squared is x plus 7. Now I can combine these two to make 2 square roots of x plus 7, but no more simplification there. Plus 1 equals x plus 12. Alright, so here's what I'm going to do. I'm going to move the x, I'm going to move the 7, then move the 1 to this right-hand side. So that means I'm going to subtract the x, subtract the 7, and subtract the 1. So that's subtracting the x, subtracting the 7, subtracting the 1 from this left-hand side. So that means I'm now going to have 2 square root of x plus 7 is equal to no x's, because x minus x is 0, and 12 minus 7 minus 1 is 4. Now I just got to get everything down to x here, so divide by 2. This is getting good here. Square root of x plus 7, and this gives me an answer of 2. All right, now I square both sides. Oh man, I better check my answer when I get done with this thing. This gives me x plus 7 is equal to 4. All right, subtract 7 from both sides. X is equal to negative 3. Now, why do I have a queasy feeling in my stomach? Maybe it's from doing this really long math problem, but moreover, I'm really worried about a negative answer. So if I check this back into my problem, you're actually going to find out everything works out okay. Because this, my friends, is negative 3 plus 7, which is 4. Square root of 4 plus 1, square root of 4 plus 1 is the same thing as 2 plus 1, so 3. And over here, this is negative 3 plus 12, so this is 9. Square root of 9 is 3. So 3 is equal to 3. Oh my goodness, that actually worked out perfectly. Wow, that is something. Alright, so we need to take a deep breath. This next problem is going to be quite the doozy, so let me give myself a nice clear board to write on here. And here I go with this final problem here. Now I have seen several professors tackle this problem by foiling both sides. And actually squaring both sides right now, but man, I do not recommend it. I don't recommend it because if I square both sides, then this left-hand side is a square root binomial minus a square root binomial. It's just not great. So let's add this square root of 2x minus 3 to both sides. And what that's going to do is that's going to simplify that to make 0. So now I have a square root of 3x minus 2, and this is equal to 1 plus the square root of 2x minus 3. I'm now going to square both sides, and this left-hand side becomes pretty easy because the square root of the square of a square root is itself. And on the right-hand side, I'm going to first of all move my equal sign over here. I'm going to FOIL this out. I'm going to go 1 plus the square root of 2x minus 3, and then 1 plus the square root of 2x minus 3. Okay, I'm going to FOIL this out. I'm going to figure out what that's going to be when I FOIL it. So left-hand side stays the same. So 1 times 1 is 1. Now I've got a square root of 2x minus 3 and another square root of 2x minus 3. So that's 2 of them, which I will then simplify in the next step. Because these are exactly the same under the radical. That means I can combine them using addition. And then if I multiply the square root of 2x minus 3 and the square root of 2x minus 3, I get the square root of 2x minus 3 quantity squared, which is going to be 2x minus 3. Okay, so I'm going to kind of move stuff to the left-hand side here. I'm going to first of all combine these together to make 2 square root of 2x minus 3, and then I'm going to move the 1 and move the 3. So now I got negative 2 minus 1 plus 3.
I am then going to also subtract the 2x. Subtract the 2x. So now this is going to give me on the left hand side here an x. Nothing else. 3 minus 2 is 1x, and these all simplify to 0. And on this right-hand side, look at all the simplification. I got 2 square root of 2x minus 3. So I'm going to divide let's see, what am I going to do here? I think I'm going to square both sides right now, because I was thinking divide everything by 2, but that would just put a fraction over here. So let's square both sides to get rid of this square root. And this is going to give me x squared, and on the right-hand side, this is going to give me 4, and then 2x minus 3. So this is going to give me x squared is equal to 8x minus 12. I'm going to move the 8x and the 12, so x squared minus 8x plus 12 equals 0. Holy moly, this is factorable. So I got x minus 6 and x minus 2 is equal to 0. Alright, I'm going to now solve for x here. I'm going to get this equal to 0, so x is equal to 6, or x is equal to 2. Again, not writing out the step where I say x minus 6 is equal to 0 and x minus 2 is equal to 0, and just solve for x. Man, I better check these answers back in the problem. So I'm going to go 3 times 6, which is 18. 18 minus 2 is 16, so that'll give me 4. 2 times 6 is 12. 12 minus 3 is 9. So that would be 3. So 4 minus 3 is 1. Hey, 6 works. Awesome. Let's try 2. 3 times 2 is 6. 6 minus 2 is 4. And square root of 4 is 2. And then 4 times, this is 2 times 4, and minus 3 is 1. Whoa, wait a second here. 2 minus 1 is 1. They both work. Well, that's surprising, isn't it? Well, thank you for watching this video. Some pretty tricky manipulation here. Thank you for getting through it, and good luck with the homework here.